Hey guys, and everyone. Welcome to the class again. So we're going to talk about a few different topics and, kind of split our time against these things. So first we're going to just go over your assignments and I'll give you some feedback. And we can also talk about some additional work you can do around the same assignment. That could be your next assignment, but this would be a shorter one than the last one because the last one was kind of longer. We did it till the Tuesday kind of interval. So we're going to do that, and then we're going to shift gears into a completely different topic. I know you've been interested in knowing about like kind of day-to-day work environment and responsibilities and stuff in the data science career. So I can talk about that from a job perspective and a day-to-day perspective. That can be kind of interactive session. You can ask me anything in there, kind of open it more informal at that point. And then we can get back to another completely different topic, which is the leftover part of our SVM slides. So we discussed up till the cost parameter and what it's doing. We can go over towards the gamma parameter, the other parameter. That will complete our SVM slides. In the coming weeks, we're going to go into newer techniques. But the pipeline that you've been building for your SVM with respect to basically the second assignment that you did, it's going to stay kind of very similar, except for the fact that you're not going to use SVM, but we're going to move to other techniques, but you would still be doing the same cross-validation and everything. So we're going to move into random forests, which is a very popular technique. It's more like a decision tree-based technique, and then we're going to move after that in the coming weeks into neural networks, which is, again, a very vibrant area these days. So before we start our call, any other questions or concerns you want to talk about or discuss? Or we can get started with the feedback, I guess. Okay, I'll take that let's continue. So I think you did a good job with the assignments. The first assignment, everyone did it perfectly fine. The second assignment, there are some more improvements and refinements that would be needed, especially because we'll be using this kind of code or this structure of code that you built for your follow-up assignments as well, at least for the coming couple assignments. So let's go over them. Let's get started with me sharing my screen. And what I'd be discussing with, like, say, if I start with Krishna Kamal, because I see him in that order. So what I discussed with his assignment would be useful to other people as well. And they're kind of similarities. You've done very kind of the good part was kind of a little similar, and the ones that were not too good. With that, I could, you could do some more improvements were kind of similar mistakes as well. So that way it will benefit everybody. Can you see my screen now? I think yes. Okay. Let me open up these files. So what do we have first? Okay, Krishna Kamal. Okay, so I found your coding structure to be more cleaner, kind of. Especially, I'm referring to the fact that especially I'm referring to the fact that you kind of made it kind of procedural with like a few functions for everything. Which is kind of a good practice. In terms of that, the code looking clean, maybe a couple improvements if I were to say on the improvement side, I would say you can probably have some naming conventions, there's some more comments in here, or say some naming conventions sometimes should be relevant. So okay. If you did say new mod, I know it's referring to some new model, so yeah. Something like that. Sometimes people try to improve there, but there's not much of room for improvement for sure on the naming side of things, just to make it more readable.
Yeah.
Okay, cool. Yeah, cool. So now getting into the logic itself. So I see what you're doing. It starts here. So those are the functions in this is your run function basically. This is what starts the code. So you took in data. You separated the x and y variables, which was the 14th one, and then basically this is something that is kind of common to everybody. What's going on is whenever you're calling then you did the splits basically based on the folds, right? This is the fold part, right?
Yeah.
Yeah. I mean, this could be done even easily as well, but I mean, this is okay for now. Was this so when you did the division with 100, I was not sure how that would reflect on the fact that you're doing 5-fold cross-validation. Your data set was how many rows? Was it 516 or more than that?
106 rows. 106 rows.
Oh, okay. Okay, so then it will refer to, okay, then it gets closer to the 5. Okay, fine. That's good then. So coming to the new, so then once you got the splits, you're passing your individual splits for the new model. Then what I observed, this was kind of common for everyone. Within the new model, when you're, the part where you're fitting the SVM function itself, here, for example, the thing is the tune internally already does cross-validation for you. That's what the use of the tune function is as far as R goes for SVM.
Okay.
So if you want to implement cross-validation, you don't want to use the tune function because then it's kind of slightly messes things up because you're passing the folds one fold at a time for train and for test, and the rest become train, which is all fine. You're passing those things correctly after the split. But then you're applying cross-validation completely on just that split. And then you're moving to the next split and you're applying, again, cross-validation. But what we ideally need is you want to, for each given parameter choice, so here you don't have many choices, right? So you have 4 of gamma and 3 of cost, right? So that's like 12 combinations of cost gamma, right? Minus 1.5 is a combination, minus 1. So you have 12 combinations. So for each combination, we want to know the average of the performances across the 5 splits, which will be your cross-validation error, which is slightly different from doing the cross-validation for each split at a time, which is not what we wanted to implement, right? That is what, so the average part is being done internally. So what you can do is in your assignment 1, there were 2 versions of using SVM. One was initially you use the SVM function call and then pass in whatever parameter you want. Versus, yeah, go ahead.
Hey, Pradeep, can I just interrupt? So here what you want us to do is give the complete set of data instead of giving a chunk of train or test data.
The chunk is correct. What I want is slightly different. So let me do some quick. This time I can use this because it's not going to be symbols and stuff. So I'll tell you the difference, slight difference. This kind of applies to everyone. So this was your data set. You know what cross-validation is. I'm not explaining that per se, but I'm just putting the image kind of similar to that. So what's being done currently is, say you have 5 possible splits. Say this was the first iteration of that, right? Where the first one was test, and then the rest was train, right? So for this split, what you did is you passed that correspondingly into your SVM tune function, right? And then you found the best parameter that is performing for this split. What I want, I will draw this side. So you are finding the best parameter for this split, and then the best parameter for the other 4 possible splits, right? Where this becomes test and the rest are train, using the tune function out of your 12 possible parameters. What we want is slightly different, which is what is done, the industry standard stuff, right? Which is what you want to do is you do the same thing again. The split part is fine. Till here you're fine. This becomes test. This becomes train. So this is the train. This is the test. Just they wrote like here. But then you have these 12 possible parameter combinations, which you had on the left side as well, and what you tried to do. This is your parameter combinations. So what you want to do is for each parameter combination, you want to compute the cross-validation error, which is the average of the 5 possible ways of splitting it, right? So this is your test, then this is your train. Next, this is your test, the rest are train. Now this is your test, rest are train. This is your test, rest are train. So you have that 5 possibilities. So you do for each parameter combination out of your 12. So for one particular cost and one particular gamma, you do that 5 times, and each time you get an error of your prediction on your on the fold that you left out. You average those errors, and that will be the cross-validation error for that parameter combination. Okay, so you want to use the average, basically the CV by K or K minus 1, to K minus 1. Yeah, CV by K. So you have 5 possible combinations. So K folds, right? So CV error by K, you want to obtain for each parameter combination. So every PI should lead to a cross-validation error by K. And then you choose the PI combination that gives you the least cross-validation error, the average cross-validation error across the 5 folds. It is slightly different from, it's somewhat different from what, this side, which you can kind of change a little bit. You don't have to change code too much to get to here. Here what's going on is you take one parameter combination and you're obtaining the cross-validation error for within that combination. So by K, the same thing is happening inside tune function, but what it will do is it will split these again and it's going to cross-validate in here, just slightly different from this thing. Any questions here?
No, it's clear.
Yeah. So basically, instead of using the tune function, yeah.
This is Kamal. Quick question.
Sure.
So yes, in short, I mean, if my understanding is correct, so instead of doing a tune, we'll do the SVM with all the combinations and take a CVE for all the average of all those parameters.
That is exactly correct. So yeah, that is what it will translate in code, right? So you convert the tune, you change the tune instead to directly the SVM, and then you can even have, because this is a brute force approach, you can have, if you want another for loop that just goes through each combination at a time, you have to this SVM with the cross-validation error, where your splitting is fine. You just make sure you get this error for the numerator for each split, and then you save it. So you get an array of 5 errors every time for each parameter combination when you pass them to the tune, to the SVM function instead of the tune function.
Right.
That will be the correct way to do it. Okay, that's good. Otherwise, let's see. I have very minor things otherwise. Yeah, which is what I wrote, right? Try same parameter at a time for all train test combinations and average them, and then you can pick based on that. So yeah, that was the only thing we have here that you can continue to work on. So we keep refining this code. We're going to use your refined codes for these 3 or 4 techniques that we're going to do in the coming few weeks. Then you can pass that into your project data set. So then you can have like a report for your project data set where you have like a table of cross-validation errors for SVM, random forest neural networks, and then you choose the one that does the best, right? You know, that kind of thing. So you're going to use this as your pipeline, and then this code will be useful to you in the future as well. If you start using these models somewhere, the more refined and correct it is, the better. It's also going to give you a lot of R practice as well because you're doing all this.
Yeah, it was a good practice with that.
Yeah, exactly. Also, this part, this is another minor thing now, specific. This part could be kind of made a little more cleaner the way this is working.
Yeah.
Anyway.
Yeah. I was more concentrating on the SVM part, so I didn't think of that.
Sure. I mean, you guys are developers in general, so you know the process anyway. We first do one pass, and then when we refine it a few times, it becomes very, very good code. So that's the process of it anyway. But yeah, once you get it working, you can do the refinements. Okay, so let's get going.
Thanks.
Yeah, cool. Let's go. I forgot. What do we have on the video? Okay, money. Okay. So let's do. Okay, I might have rewritten this. So let me open up your assignment. Okay, cool. Oh, you're here. Okay, somehow I didn't see you. Okay, good. You're already here. Okay, so there we go. So overall comments, things look clean for sure, which is good. Overall structure is there. So since we're building up on what we've discussed already in the previous, the other assignment, so what's going to happen is similar changes. If you see what you did is your y is 5, which is the 5-fold. So you're doing this 5 times, but there's two changes that is more specific to your approach, which is you did within the for loop ended here, right? So you basically did the cross-validation 5 times. And the same thing, the tune is kind of internal inside, and then you're passing all the parameter comments. So same thing. You basically want to change this to SVM, and then you can maybe get in another for loop outside, which will go to each combination at a time, and then you get the averaged cross-validation error. As far as the splits go, let's see again more carefully. Okay, so this is your total rows. Here you're getting the one that is above the ceiling. This is just a sequence of numbers, right? If I'm not wrong.
Yes, Pranit, it's sequence of numbers.
Yeah. Okay, so you have that. And then you take the sampling. And okay, it might be a good idea, a good practice, whenever we sample, not just for this project, to save the result of your sampling uniquely. So you can say, sample IDX or something like that is equal to that, and then you go based on that sample. Because every time you run this, you're going to get a different shuffling, especially because it's a for loop. It is definitely running multiple times.
Yes, Pranit, actually so the sample is going to change for every run. I'm taking it in the different files of export CSVs. You see the generate file name and write to file columns.
Let's see.
Yeah, whenever we get the sample, it's gonna just above. Yeah.
So ideally, what we want to do is we don't want to change the sampling. So you only shuffle your data once, and then all you do is you only split it into five subsets, right?
I tried it, Pranit, with the first try. I split it into the 5 parts, and while taking off the column 14, it went difficult for me to minus the rows, already selected rows from to minus the selected rows from the total data set. It's been difficult for me.
Oh, okay. So it is very similar to, say, let me do something.
Now it's made easy because I've added a unique column something. That's what Manish gave me this idea.
Sure. Yeah. So basically, if you had a example data frame, so this is not going to run because we're not going to press enter because it's not loaded here. If that was your data frame, well, let's call it example data frame, and then can you see, or is this blocking what I'm typing? Oops. You can see my R Studio, right?
Yes, Pranit, it's loading very slow for me. Yeah, but I can follow up.
Oh, okay, yeah. So there's some lag. Fine. So if you had basically the fold, say if you had a list called fold IDX, for example. This is, by the way, like you guys know, not just in R, any programming, you can do the same task in maybe 100 different ways. So what I'm showing is just one way. So say if you had fold IDX as a list data type, for example, where if you initially what you do is you sample your data, right? So you do train IDX is equal to sample of n row of train data, n row of your input data, right? Input data, comma, something like 70% is what you want to sample, right? 0.7 star, that. And then also be very careful to put in replace equal to false. There are two kinds of sampling. One is whenever you take a sample, you put it back and then take the next sample, next thing. there you'll have a repetition happening, that is sampling with replacement or without replacement. So you don't want to replace because you don't want to have the same row repeating twice. So you can do that, and then that will give you some train IDX, right? Now what we do is let me do it here for you, just to give a quick structure. Okay, and then that'll give you train IDX, and then you know how to figure out the test IDX, right? One thing I can do is say, I can do a set difference of all the rows. So sequence of 1, end row of, this is a sequence of all numbers from 1 to number of rows I have, and then I can do train IDX. So whatever, so this is a set difference. So whatever is not in this, that is in this. So basically the rest of the rest of the samples, which will end up becoming test IDX. Something like that you did. And then a nice way would be to use a list data type. It's kind of popular. So you can do, say, folds, right? Fold list. You can create a list data type, and you can make sure that when you split this into 5 parts, you can have just the indices split, basically. So fold IDX of 1 will have the indices that correspond to the training for the first fold, and 2, and so on. And once you do that, the specific question that you asked is, if you want to pull, or let me know if this was the question. If you did something like this, fold list of 1, say 1 was having the indices for the first fold, for the first fold, which will be your test data, right? It will be your temporary test data. So that is the first fold. If you do something like that, and if this has just the numbers of the rows that correspond to first fold, it may not be in list, in whatever format you have those numbers somewhere stored, then this will just give you the training rows that will end up in test data, right? Is this going towards where you got stuck, or is there some specific issue that happened while you're where you're trying to pull some rows from a data frame? Hello?
Yeah, yes, Praneeth.
Yeah. So yeah, if you can ask me if the specific question where you were trying to get stuck in terms of pulling rows, or
Okay, so you have selected this train and test, right? So 70% of it goes to train and the rest it goes to test.
yes.
Okay. Okay, how to take off the 14th column from the both of it?
Oh, you want to remove the because it is the train Y column? Oh, I see. Oh, there are 2 ways. One is just if you had a data frame where you want to remove the 14th column, say, just for example, if I'm doing it here, so all you do is this, right? Minus 14 input data. That is one way of doing it. Another way is if you know the column name, to keep it cleaner, you can just put in the column name. Another way is there is a function called subset, and there is drop option in it. So subset drop or.
So Praneeth, the k-fold means k as in the number of splits, not for the iterations, right?
Yes, k is the number of splits.
Okay, that's where I think we did the mistake.
Yes. So if you see
because it said in SVM while calculating this cross-validation error, we have to k-fold means okay, let's say it's 5-fold. We have to take one part as test in first iteration, and the second part as test in second iteration, and third part as test in third iteration.
Yes. When you do that 5 times, you get 5 errors. You average those 5 errors. You get a cross-validation error for one particular parameter.
So, but we are doing it 5 times. It's 5 iterations.
Yes. You choose one parameter combination, then you do 5 iterations, where in each iteration you drop one fold as the test, the rest become train. You have one error because you picked an SVM for that combination. Then the parameter stays the same. Next time you drop the second fold in the second iteration, you use the rest of the 4. You put an SVM, you get an error. You save that error. You save 5 errors for the 5 iterations, you average that. Then you have the cross-validation error for just that particular parameter. Now you do the same thing for another parameter. The whole process gets repeated. Then you choose the parameter that gave you the least cross-validation error.
Okay.
As far as the method goes, that needs to be implemented. So if you see, I wrote similar thing. I wrote for loop repeated the CV 5 times, right? Kind of because the tune was inside the for loop. You want to mimic this part. So what you want to do, if you I see you some more insight from what you asked. So in terms of the iteration part, what you're iterating through is definitely for I in say 1. This is like a skeleton code, right? 1 to say num folds, right? That is something we're fixing beforehand. Even if you make this a function, you're going to pass 5 there, right? So that is the structure. And then let's just do some more for loops around this. And then obviously before that, there would be another for loop, which would be this could be j now. Now this would be I in 1 to n row of, let's call something called pair grid. I'll tell you what that is. So pair grid is a data frame that will have is equal to m dot grid of. There are some different tricks you can see while I'm typing. Let me type this line, then I'll tell you. So standard grid of gamma equal to CF. Let's just do then cost equal to CF. So we have 4 combinations of cost and gamma. If I use the expand.grid function, it will generate a data frame. So grid in a comment is a data frame with now you have 4 rows, right? By 2 columns because you have 2 parameters. Basically, each row will have the unique combination of cost and gamma. So each row, so pair grid of these all comments will give you, if you pull the first row, once you generate pair grid using the expanded grid, you will have 1, 2. So the first row will have 2 entries because the first combination of gamma cost is 1, 2. Then you will have 1, 7 in the second row, then 2, 2, and then 2, 7. So basically, you will know. So if you go through each combination at a time, which is what we wanted to do, right? We wanted to implement going through each combination at a time. So each parameter combination is fixed, then you do the entire process of cross-validation correctly, right? So you go through this and then you save your parameters, right? For that particular purpose, cost equal to pair grid. It will have a cost. It will automatically have the column name as cost, so you don't have to put in fancy numbers of I, and then gamma dollar gamma of I. So what is going on? If you see just the for loop structure, you're going through each unique parameter combination basically. You may use expand.grid or however you write it, it's fine. You go through each unique combination. You're pulling that particular cost and gamma, which is only one particular cost and gamma. It's not multiple like in tune. And then for that particular cost and gamma, you're going through 5 folds. And here, if you have a list of because you need to know which indices are first fold, which indices are second fold, which indices are third, which indices are fourth, which indices are fifth. That is the least thing at least we need to know because so that should be stored somewhere in say fold list, or it could be a data frame, whatever your combination is. But you should know which is what. So each time we're going to do S data is equal to fold list of the indices of the ith fold that you're pulling from your data set, which is your input data of that, right? So that will be your S data. Similarly, train data will be anything that is not in this. So you can put in a negative basically. So you can do train data equal to the rest of it, which is what you want, right? Because 5 times, each time you fix the test and train to be one particular thing. Then the second time, another particular thing. That's what you're looping through basically. and you do this. If this does not work, it will be a slightly syntactical thing. You have to do unless of this, something like that. Either way, there are different ways to, but that's the overall structure that I'm writing here without running it because I don't have anything to do. So now what you'll have is you will run the SVM here using the SVM function. You know the train X, train Y and everything here based on this. So you'll have some error. So that will be saved in CV, or you can call it fold error of J equal to the error that you got here, basically, that you calculated above. It's going to be just an array that you're initializing. So by the time all 5 folds are done, you will have, for each parameter combination, you will have an array of 5 errors, basically, that you average up. So once all the 5 folds are done, here you do CV error equal to mean of the individual fold errors that you got, right? So this CV error, again, should be unique for each parameter combination. Make this big. Should be unique for each parameter combination, right? So for each cost gamma, you should be able to save that. So this will be another array, but it will be running on I. So ith parameter combination has CV error, which is obtained by averaging the 5 errors. That's why this is J average. This is this one. Okay. So that will be the overall structure. So in the end, you will have every cost gamma combination and the cross-validation error corresponding to it. That should be the output data frame to however you do this. You don't have to use these same tricks. You can use your own way of implementing it, obviously. Your choice of functions or implementation logic. But this is how you need to do it, right? So you're almost there. You have to change a couple things in terms of the fact that you want to loop through parameter, one combination at a time, and then instead of using tune, you want to use the SVM inside, basically.
Yeah, it's a good.
Okay, cool.
And I have a piece of code I tried for the first try. If you don't mind, I can share. I can share my screen.
Yeah, go ahead. I will stop for a second. Yeah, go ahead.
Oh yeah, I got it.
The arrow. It has loaded, yeah.
Oh, you can see that?
Yes.
Okay. Okay, this is the first I tried. Okay. Okay, this is the number of folds. Okay, I just tested this. It's printing 1 to 5 sequence.
Yeah.
And I divided into how many folds we want, and I got like total we have 506 rows, and I took 102. From this, I choose as low bound as 0 and high bound as number of rows 102. So first 0 to 102 as one set.
Yes. Yes.
And then it increases on here. See, low bound equal to low bound plus number of rows.
Yeah.
So
this is a common. This is well done. This is good. This is better code as well. I agree.
Yeah. So for 1 to 5, I've made a 3. So this is the aim. I divided into the whole 5 parts. So from here, I got stuck, and I made another approach, like which I have sent to you.
Yeah, yeah. So yeah,
the thing I got stuck here is for the first part, for the first iteration, I can take this first part blindly as a test part. For the second iteration, I want to. Okay, the easy way is we have to minus this from the whole data set.
Yes. Yes.
Train part 1, dataset minus train part 1 as a train dataset.
Yes.
So how to do that, Pranit? When I did this dataset minus this train part 1, I'm only getting 94 rows. Like,
no. Here there is okay. What you are aiming to do is exactly correct. Your aim is correct.
Yeah.
The one only the syntax part. Some issues are coming. The thing is, 2 things. One is the train part here is already a data frame, right?
Yes.
So separating the rows in a data frame based on the values based on given rows is a little difficult.
Yes, that's what I was like surprised. I got an idea up to here. So I see.
So what you want to do is you want to do this save. What are the indices that end up in train part? What are the indices of the original data set that are in train part 1? What are the indices that end up in train part 2? Then you can always separate easily, like this comma kind of an approach. You want to remove those rows, you just put the IDX in the data frame.
Okay, so like we added unique column like that.
So instead of, all I'm saying is if train part 1, if you had something called train part ID X1,
Okay.
X1, right?
Okay.
If that
Okay.
only row indices of what rows should in original data should be part of the first training part, first fold.
Okay. Yeah. So if that works, then this approach will be like I felt easy instead of adding another column and all. But I got stuck, and Manish helped me like adding the unique column and that idea.
Yes. If you have indices, you can always drop based on that, especially more easily. So you can drop which rows should be in training part 1, which rows should be in the rest of the test part, like that. The second comment was another different thing. Here, if you see, if you literally hardcode train part 1, train part 5 like that 5 times.
Yes. Yeah. Like I've got it in the main assignment, like how to
Automate.
Yeah. No, this is like see, this is I automated it into the variable train part 1 and all.
Okay, good.
Yeah, like this. See, this will create all this train part 1, 2, 4, 5. Like based upon y value, if you give 10 here, it will give 10 train parts.
Okay, then this works. Yeah, I thought you literally hard coded that line. Okay, you did a paste function. Okay, that's fine. Then it's good. Okay, it's scalable. Yeah. Because if in the future, if I say I want to use your function for 10-fold cross-validation or leave 1 out,
Yes,
I should be able to. That is not an issue then, yeah. Only the thing is, if you had this, if you wanted to separate from the training and test in these iterations, if you had indices numbers, just the row indices, it will be easier.
So yeah, so I need to get row indices here.
Yeah, corresponding to each train part or fold, whatever your terminology.
So that must be a unique row ID or something like that.
First you sample, you shuffle your data set. Then you split it into 5 sets. So if your data set is 1000 rows, 516 rows, all you do is you take numbers from 1 to 516 and sample it. So you'll get shuffled numbers of 1 to 516. Uniquely shuffled. And then all you do it is you separate it into 5 chunks. Of row just the numbers are being separated. So I will say row number 1, 7, 9, 13, so on so will end up in the row numbers from first training fold, second training fold. Once you have those row numbers, you can easily access those rows using the comma notation like you did in line number 130. Here you are accessing columns. Similarly, if you had put in for the training part 1.
Yes.
Okay.
Yeah.
I think yeah, you have some programming background, right? This is the any assignment in one pass perfectly, right? So even if you do a very refined, keep on refining, right? So it's that is sometimes if you end up like some deer on the somewhere number 2 is in that issue. So you keep refining the code, yeah. Okay, so 1, 2, 1. Okay, Manish had a GitHub link. I don't remember. So yes, that's true. Okay, so one. You can see the screen? Okay, so
I think I need to clear a lot of code, but it's commented.
Yeah, that is maybe the overall comment would be a little bit of that, which you can do. Then so you have the exact same thing going on. You're using the tune function, which is doing cross-validation, complete cross-validation for just one combination of fold, right?
Okay. Yeah.
Same thing. So
yeah.
Otherwise, everything's fine. You have to clean up your code. Just come up with that structure. Feel free to use multiple for loops, like nested for loops. One for the folds, one for the parameter combination, and everyone should have the output being this one thing, same format though, which is matrix or data frame, whatever it is list. But it should basically have these 3 numbers for each combination of cost and gamma. What is the cross-validation error obtained? That should be the number should be the output.
And I introduced a new row in this named ID just for my calculations. So is that a good approach to take? I mean, in the real world?
Yeah, good point.
Like,
Yeah, I remember seeing this initially when I went slowly. Now I'm going in the call quite quickly, but this is true. You don't need to do that actually, right?
yeah, I should have used sampling, but
Yeah,
I went with that, and
yeah.
yeah,
You definitely need to do the sampling. Yeah. Thanks for bringing that up.
yeah. And then I use this random number function to pick things randomly, and
Yes, and then this is the second issue, which is, yeah, to be very specific now, this is, yeah, another thing, right? Your sample will automatically change every time you're running in the for loop. So you only want to sample outside all for loops, which will shuffle your data only once. The point is, shuffle the data once, and then you split it into 5 nodes. From a learning perspective, the reason we want to shuffle it is because if your data set is, say, in an order of increasing difficulty to do classification, then these rows may be easier to classify. These rows may be harder to classify, whether it is a cat or dog or diabetes, no diabetes, whatever, housing prices, this or regression perspective. Maybe these are easier rows, these are hard rows. Then if you don't shuffle your data set in your fold thing, you're implicitly, this is called selection bias. You're implicitly biasing your algorithm. Choosing parameters that may be not properly chosen. Your choice of parameters works everywhere, right? Yeah.
But internally, I'm shuffling the data again, like.
Yeah, but you don't want to shuffle it multiple times, because then the cross-validation error that you obtain for one particular iteration, where say for this fold is test and the rest of the time, will be is different from the cross-validation, because you're changing the input question paper for every time.
Yeah, I got it. Like I might be using the same parameters sometimes in some cases.
Yeah. Exactly. And also in the future also, at the next level where you're doing this for each parameter combination, this parameter combination is tested on a different train and test version than this parameter combination. So things are not comparable. So that is one another reason is that selection bias, right? You want to shuffle up.
Yeah. And then I subtract the data, that all.
Yes. So yeah. So same comments basically. My comments are reducing as we go to last and last, because it's been similar stuff, right?
Yeah.
So, same thing. Okay.
I'll improve the code a little bit.
Yeah. So you can work on refining this. So basically your next assignment is just refining this code. Yeah. This first version of code, whatever technique you did, SVM, for now you're doing SVM. The more refined this is, the better it is, because you will be just using this code on different data sets. So change this parameter combination to be a bigger list, instead of smaller list of costing numbers. Then we'll identify which is the best. That way your performance of your engine will keep improving on your project data. Sure. You can compare to different techniques. Because in the future, when we go to random forest, nothing changes. If you had a proper refined version of this code, only thing that would change is this function. Instead of doing SVM, instead of doing cost gamma, there are another 2 different parameters. That's the only thing. It will be very nice, reusable code. Okay.
Sure. Thanks, Pranay.
Yeah. Good. So yeah, good. Let's go. I think right. So this one. Yeah. Here is the code. And so the comment. So okay. So this is the same thing again. So basically, try the same parameter at a time. So one parameter at a time for all combinations, and then average them. So if you see in the code, in the first assignment everyone did fine, right? Okay, so let's go to the second one. Okay, the good part on the overall comments, the good part is you did the folds in a very nice way. It's super quick, right? You just choose the breaks. But I'm not sure if you shuffled your rows though.
Yes, Pranita, I didn't shuffle the rows. I just did the folds on the set directly.
Yeah, so the shuffling can be done very easily using the sample function. So,
yeah. I could just first shuffle and then cut the data set into 5 folds, right?
Exactly. So this is the data reading part. You can put a comment and then separate here. You say shuffling, randomization, whatever you call it. Here you shuffle basically, and then everything else stays same. This is a very good way to do the, now you literally have the folds that you can access.
I got the indices I have 5 different indices for 5 different folds, and then match them and then put them into train and test data.
Yes. So this was the approach that I was trying to show here as well when I was doing. In some format, if you have the folds, which fold clearly, whatever format data type it is, then everything internally you will use the same thing. You keep dropping the folds as required for changing your train and test based on each thing. So this is a good approach actually. That's why your code looks much shorter as well.
Right. I was wondering if that was the right way or if.
No, this is a good way. Yeah, there is nothing right and wrong. Anything that works is right, but this is a much better way, refined for sure. Yeah. So
I just Google functions to, match the array indices and then.
Yeah.
This is a better way to. I won't have to write much code in this.
Yes. So this is the training test part. This is good. Then this is the one. Now that's the overall comment, but the changes definitely need to be done here. You don't want to tune for one fold at a time. Internally, again, another 5-fold cross-validation is happening when you pass it to tune. Use the SVM function instead, and then you also want to add in another for loop that goes through one parameter combination of cost and gamma at a time.
Now I actually understand what do you mean by for each cost and gamma, that when you, in our assignment, we had a question, we had one point saying that you should have your cross-validation error for each cost and gamma, right? When you actually told us this, there should be another for loop for each cost and gamma, that's when I understood that you actually asked us to implement that one.
Right, exactly, yeah. Because that is when you will be able to see plots like, you will know for each. So let's assume we only had one parameter, right? The same thing generalizes. It's harder to draw 3D, right? Even if I use my writing pad. So say this was your cost gamma parameter combination, right? Say this was cost, for example. So you really, what you want to know is at what parameter on the x-axis your error is the least for the cross-validation. That is why we are doing cross-validation. So if you don't know the error for each parameter combination, you will not be able to compare where the minimum is anyways. So we want to do this, you're trying say 12 combinations, so you can try more as well or less. But then you will say where you got the minimum, but just by in the end in your data frame, I will see for which row do I have the least error, and then that row corresponds to some particular cost and gamma, then I know. Then I have trained my SVM because I know what cost and gamma I will use for that particular data set when I deploy it into my production system or in my research or in company, whatever. So, but also obviously we cannot do without cross-validation, because if you just go by training error, it will keep on reducing as you keep increasing your complexity of your parameter.
But Praneeth, but even in TuneNet, we get different cost and gamma, right? We are getting different cost and gamma for every tune. How is it that, how that cost and gamma different from what we get in SVM?
If you did the, okay, yeah, good point. So if you're not changing anything, right, and if you're only passing the entire data set to tune 5 times for this with the same range of cost and gamma that it should be searching from, you will get the same, only one best cost and gamma. It will not change. Okay. Because your folds, what your input you're passing is changing every time.
Oh, okay. Yeah. It is changing because of the training data or the training test data that we are using, not because the SVM.
Yes, your input data is changing. So obviously the parameter will change a little bit. That's why what we want to do is this approach where this is just an overall skeleton. What you want to do is you want to take one parameter combination at a time. Then you have one specific cost, one specific gamma that you're looking at first.
Right.
For that, if you do cross-validation,
Mm-hmm.
you'll get only one error. If you repeat it again and also you'll get one error because your folds will not change. You have fixed which one is first fold, which one is second fold also before you started doing cross-validation. Nothing changes. You'll get one error. Even if it changes, it'll change slightly with some small floating point difference on some decimal value.
Yeah.
Then go to the second parameter combination, you do this again. Third parameter of cost and gamma, then you do this again. Then you choose which cost, and basically when I do it again and again, I'm getting these different points of error. At some cost gamma where I get the minimum, I will use it basically. Okay, cool. So yeah, it was a good start. You guys all of you are like basically thinking through and coding everything. So your approach is fine. So that is good. all we do is we're just refining the code. We're also trying to get the input-output requirements correctly. What is it we need to implement? How do we do it? And all that. So yeah, keep at it. I think let's try to get a refined version of this, and that should be our next assignment. Same data set, everything, just refined version of the code so that the cross-validation is being done correctly.
One question. You wanted this code to be as a function so that we could use this function for different data sets, right?
Correct.
So I am not sure how to write that into a function.
So it should not, if this part you do the refined version like we did, right, we discussed, then it should be very easy actually, because this is the harder.
You asked us to send train and test data as a parameter. So you just want you want us to iterate through from the first train and data that their function sends.
Yeah,
right?
so basically the function is this, that is right. All that iteration, everything happens internally. The function is this, right? Let's call it CV1 something. CVML. This is a function. All I pass here is just some folds. I can pass 5, 10, whatever. For now, you can fix it as 5 if you want, and then just the overall complete data set. I can just pass say train data for X, or like train X data, or like let's call it X data. You can change it slightly the way you want it. Y data. That's it. This is like no train test has been done. This is just the input variables, the output variables. That's it.
Okay. I was wondering how if we send a train data X and train data Y, how would I iterate through if I don't generate them in my function?
I'm not sure I got your question correctly, so I want to listen again. Can you say that again?
In my function, I would have to generate the train and test data, right? I cannot send the train data as a function parameter.
In this overall function, you have to generate internally. If this is the only function you want to write. Inside, you can break it down into multiple functions, which you can separately call by writing separate functions outside. So I see. So what you do is if you write something like this, then your X data, when you're calling the function, that itself would be your train data, right? You can call the function as saying CVML of train X, train Y. And then I'll say num folds equal to 5 in this sort of usage. And then you could have generated train X, train Y separately if you want. Now, confusion some more is you apply usually in reality the cross-validation is applied only on the training data. You do your everything and then you see for your best parameter where you got the least cross-validation, you will see how the performance is on the test data. That is called the test error. So you could have passed like this or you could have passed the entire data as well instead of the train and test, complete X and complete Y. Either way, the cross-validation, as far as this function works, then we can figure out what to pass into it based on requirement.
Yeah.
Yeah, cool. So only these things have to change. The tune thing part should go out and then maybe another for loop that goes to each parameter. And then your return should be also very clear for everybody. Return.
I didn't return my CV error.
Yeah, so cost, gamma, CV error combination. I mean, this is not the right syntax, but those 3 numbers should come out, be it in data frame matrix, whatever. Printing it out or whatever, yeah. Okay, cool. So yeah, that's the assignment part. I know we spend more time, but this is a very important part where this is one exercise which is kind of really like, since you're doing it hands-on, it will really teach you a lot of fundamentals very strongly through this correction of mistakes and this and refinements and stuff. I know we have 2 topics. One is generic data science discussion. Is it okay if we keep that as the first thing we do next call? Because next call we won't be having this generic discussion that longer. Because this time I really wanted to go through this particular assignment very carefully. So we can have the generic data science discussion in the next call about the job responsibilities. That we can do for 15-20 minutes. And then the rest of it will literally be, going through the next syllabus, this next part of the syllabus. And as far as the feedback for what you're doing for this assignment, mostly I will give by email this time. Because at least we clarified the input, output doubts and everything. So that way we can save time on the assignment, the improved version of the assignment feedback. I can do that by email. Is that okay for now? Okay, so yep, I think we call it a day at this point. I think the call can be stopped from recording.